Good morning, everyone. Welcome to Data Physics Coffee Break webinar series. Today, we are going to talk about playback analysis in SignalCalc 900. My name is Kalyan Vitta, and I'm the product manager for the Signal Analysis product line at Data Physics. Let's take a look at the agenda. We will talk about recording selector, how to narrow down on a recorded file. We will look at the construction of a playback test, and we'll go through the whole playback analysis process. Playback analysis in general implies that you are playing back and analyzing data from a recording as opposed to taking data live. There are a number of advantages when playing back or analyzing data for a recording. We will see some of these advantages in this session today. Playback analysis from a throughput file or reanalysis is simply the ability to process the same data by applying different parameters. These parameters could be changing a different window to see how it affects the data. So if you're using a rectangle window, applying a Hamming window or a flat top window, how does that affect the data? In a different case, you might need to increase the number of frequency lines to get better resolution in the frequency domain, or applying a different averaging technique. The idea is to understand the data from different viewpoints, perspectives to capture the complete picture. If you have a recorded file, you can process it as many times as you want. We did a detailed web seminar on how to record time data in the 900 system. The recording is available on our Data Physics YouTube channel. If you already have a recording that you're planning to analyze, continue with this video. If not, I would recommend to view the time recording video first, followed by this playback video. Now, let's switch to the 900 software. So the screen in front of you is a typical 900 database with all the different tests under the tests section. The construction of the 900 user interface with the different sections on the top were covered in detail in previous videos. For today's playback analysis, I will be spending most of the time under the manage test section and the run test section. So as I said, under the tests, we can see all the tests at a glance. And similarly, if I click on my recordings radio button, I can see all the time recordings, the full length time recordings. These are not the individual frames, but the complete time recordings as well. Under the recordings section here, you can see the name of the recording in the first column, the associated test name, the time when it was created, the location of the physical file. If it is on the computer, it would say data server, or it could be on your 900 unit. But we recommend to right click and move to data server to make the playback analysis faster. You can see the sampling frequency of the recording, the size of the recording, as well as the length of the recording. So this view gives the complete picture of all the recordings, and it would help to narrow down the recording that you want to analyze. So once you know the recording that you want to analyze, just by physically looking at it, or you can even just come to the main search and, for example, let's say plate structure. So it would narrow down our recorded file. And once we know the recording, I can simply, for example, just this compressor wipe data is of interest, then I can simply double click on that particular file. And now we are in the recording selector. This particular menu will help further to make sure the recording of interest that we want to analyze. On the left side section here, we have a smaller view of the files, the recorded file information we were looking before, with the recording name, the test name, the length, all the other key parameters of that file. And once I select a recorded file on the right side, now we are going into the recording. I can see the big picture inside the recording. In this particular throughput file, I have 4 channels of data with tag data in it. Now, if I click on a different file on the left side, in this case, I have a lot more channels, close to 100 channels with their respective channel name, the sensitivities, the engineering unit, coupling associated with that particular recorded file. If I click on the Jim Beam, where we did a modal test, you can see the first channel is connected to a hammer, and the remaining channels are accelerometers and one just measuring voltage. And in this file, it's just 2 channels of data. All right, you get the idea. So on the left side, it would display the recording name, and on the right side, the number of channels within and the parameters specific to each of those channels to make it easier for selecting the throughput file. To view the signal under a different channel, I simply click on that channel number here. And to analyze the data, I click on the Analyze button, and I can analyze this recording with any of the measurement types. I can analyze the data using auto power spectrum, transfer function, synchronous average, order tracking, real-time octave, depending on my application. On the right side, I can select the default template or a different template. We did a complete session on how to create and use test templates to make your analysis faster. In this case, I'll just stick with the default template. Once we are within the test, it is very similar to a live measurement. So there is not big knowledge curve from analyzing a live test to a playback test. The construction of the test is very similar. We have 3 tabs, starting with the test tab, the channels tab, where we can select the channels of interest. We don't need to select all the channels. We can select the channels we want by simply clicking on them. And on the last tab, the auto power spectrum, this is where we can define the bandwidth, the number of lines, the window, and the averaging technique, so on and so forth. You will notice that while running the test, the user interface is very similar while running a live test. The big difference is we can also view the recorded file, the complete time recording from one channel or multiple channels. In this particular case, I have channel 1 through channel 4 displayed on my playback analysis window here. If I just want to select few channels or a particular channel, I can clear all the channels in the bottom and simply click on the channels of interest. In this case, I just have my first channel displaying, and on the left side, we have the control panel and all the parameters at your fingertips. You can select, change the bandwidth, the number of lines, as we talked about before. All of these could be customized, changed, and you can do a playback analysis, analyze it. And under the mode, instead of saying live, it would say playback analysis. You can also select a different file just by clicking on the ... and you can simply select a different throughput file to analyze right here. Once I start my test, at the bottom window, you will see a red line tracing through going through the throughput file, indicating the current location of the analysis. And on the right side here, I have my speed control. So this is how a live measurement would be done, but we have the luxury of the throughput file on the computer or on your 900 unit, which would make it make the process much faster if I like. So I could analyze with ×4 if I want to breeze through the section that I'm not very particular about. I can increase it to 8 if I want, or I can go all the way to the fastest. So let's go to 64, for example. So you'll see that how fast the measurement is going. In the same way, if I were to synchronize with a real-time event to see exactly how the process is being done, I can slow it down as well. So let's take a look at my signal here, and maybe G11, and I can move this up. So I have X1, G11, X2, and G22. Let me change the colors so you can see it better. All right, let me go ahead and click on stop and click on end. So as I mentioned before, I can change my bandwidth of interest. So I can select a different bandwidth, and the system will automatically decimate and use the correct sampling frequency, and it would optimize all the settings to process the data. In this case, I'm using a bandwidth of 200 Hertz and 200 lines to get a T-span of 1. And I'm going to start this test one more time so we can actually see the process. So it's as simple as changing the parameters that you like on the left side and simply clicking on the start button. All right, let's go ahead and close this test. I want to show you a few more tools while selecting the recording. So it's the same recording, the engine recording, and we are on channel 1. On the top left side, we have some tools that would enable you to zoom in on the file, zoom in, zoom out, or you can do a zoom rectangle if you're interested in particular section of the file. So I can simply come up here and zoom in on that section, and I can also pan left or right. I can grab the data and go left or right. Right, and if I have a cursor here, if I put a single cursor, and I can click on the zoom in, So you can actually see, I can zoom into that particular signal here, and I can do the same thing. Using the hand, I can go left or right. Okay, let's go back and let's look at the complete data. And on the top right, I have the ability to see multiple channels at the same time. I'm viewing just one channel right now, but if I select multi-channel, and I can simply click on the channel of interest, and it would add a separate graph so you can view all of them. And if I click on the plus, so you can see it zooms synchronously across all the graphs, so you can see the corresponding data across all the channels, which is very useful. I can also click on the minimal graph if I want to overlay all the channels of interest on the same graph. It would minimize and it would show the least number of graphs, meaning that the minimal graphs will take into account the unit, and if it is all acceleration units, as in this case, it would show you in one graph. And if it is, for example, newtons, then it would show all the acceleration channels in one graph and all the force related signals on a different graph. Now let's switch to a different file. Let's click on this file called uplate. And in this case, I would use a template. Very similar to before, I can look at my channels, and I can look at the different parameters. I can change, for example, instead of hand window, I can select a rectangle window. You can see that the process is exactly the same. You select a recorded file and simply click on start, and it would start analyzing the data. In the previous case, I have a longer file, and in this case, I have 45 seconds of data. If I want to loop the recording, I have full controls of which here I can select the repeat, and I can select the number of loops. So if I want to loop this and analyze it 5 times, then I can certainly do that here. Or in other cases, I want to, instead of playing back the complete data, I want to focus on the segment of interest. For example, if I want to just analyze the data between these two cursors, I'll place my cursors, my double cursors, and click on the min and the max, which would lock the cursor locations, the first cursor and the second cursor. And if I click on initialize and let's increment, and it would play back the portion just between the two cursors. Also, one other useful feature is if I want to capture just the significant data here. So let's look at this data. It's about 0.5 G. So I could use my trigger input channel, and on channel 1, and I am using engineering units, and I will say 0.5, and you will see that when I click on initialize and click on start, it will say waiting for trigger, and only when it sees more than 0.5 G, then it would capture the data. So from between these two cursors, I have 1, 2, 3, 4, 5, 6, and you will see 6 frames. And I can expand that if I want to capture the entire throughput file or the entire recording. Make sure I have to click on the minimum and the max buttons and click on start. You will see here on the status bar waiting for trigger, and only when it sees the 0.5 G amplitude, that's when it would capture the frame and add it into the averaging. So in this particular file, I have 20 frames. The data is exceeding 0.5 G. All right, let's look at one more example. Let's select something with the tag data as well. This particular recording has 4 channels of vibration data as well as some RPM data. So in this case, it's going from the RPM on the y-axis is going from all the way to maybe 100, 200 RPM to over 6,000 RPM and stays flat, and then it coasts down. All right, instead of auto spectrum, in this case, I would pick a synchronous average. I will also pick a template. If you have the template created ahead of time, it makes the process so much easier as well as faster. Under the channels, I have all my channels selected, and I also, based on the template, the tag is also checked. In my synchronous average test, I have the usual parameters, the bandwidth, number of lines, windows. In addition, I am capturing a waterfall by pacing the event and going from capturing the data starting at 600 RPM all the way up to 6,000 RPM, and I'm capturing data every 50 RPM step. And I also enabled my waterfalls. Based on this, I'll get roughly 109 records, and I have my G11 and G22 as a waterfall signal. And on my playback analysis window, by default, it will show the first 4 channels. I'll clear that, and maybe in this case, tag would be a better signal to show. I click on initialize here and click on start, and you can see waiting for pacing, next RPM at 600 RPM. I can make this faster. Let's go with 4 so you can actually see the cursor moving faster. And on the top window, I have my waterfall graph, and I'm capturing, based on the pacing delta, I'm capturing every 50 RPM on my waterfall graph. Each record on my waterfall is a 50 RPM step. That concludes today's session. In essence, if you have a critical project, we highly recommend to record the time domain data so you can process at any later time. If you want to reinforce some of the topics that were touched upon during the presentation, please visit our YouTube channel. Thank you once again for being with us today and spending some time with us. If you have any questions, please email me kalyan.vita@dataphysics.com or visit us at dataphysics.com. Thank you.